Okay guys, today we're going to go through our surface area. So in our measurement unit we have gone through length, which was finding the length of something, which was more one-dimensional. Then we've gone through area, which was finding the space that something took up on the 2D plane, and that was more two-dimensional. So 1D, 2D, then we went through volume, and that was three-dimensional, so that was how much an object took up, how much space an object took up. And then what we're going to go through today is actually, it's in 3D space, but it's a 2D measurement, and that's surface area. Surface area is really important because later on in calculus and level 3, NCEAT level 3 calc in year 13, you kind of want to optimize the amount of material needed to create the surface of an object and maximize the volume. A really neat piece of engineering that does this is the cylinder. So that would be your tin cans, your cans of Coke. The best object for surface area to volume is a sphere. Okay, so a sphere is the least amount of surface area, but has the best volume. But what the sphere lacks is stackability. So if you try to stack lots of spheres together, you get lots of empty space around it. And so what we do is we go halfway between a sphere and a cube, because a cube obviously has uses a lot of surface area to volume, but it stacks perfectly. And so what we do is we go halfway between a cube and a sphere, and we use cylinders. So a cylinder uses a mixture of both, because you can stack them really close together, like that. And you basically have very minimal waste of space when you're stacking them or transporting a whole lot of them. But they also use the part of that sphere that uses that curved surface to optimize for the amount of tin or aluminium for actually creating the shape. So without further ado, we'll get into some problems and we'll try to calculate the surface area. So basically surface area, think of it as how much, say, sheet metal or how much material do I need to actually create, say, an empty box. So not how much space or volume it's taking up, but how much material is on each face. And it can get quite complicated, and it can be quite easy to forget one of the faces. So what we want to do with this cuboid, we've got a 10 by 5 face. So we have 10 times 5. Plus we are going to have, what's this one? This one here, well, that's an 8 by 10. Plus we want this top one, which is a 5 by 8. And so, and each of these faces there's two of them, isn't there? So on the top, there's also one on the bottom. This face here also has one at the back, and this face here also has one at the back. And so have we hit all 6? 1, 2, 3, 4, 5, and 6. So we need all 6. So when we do these calcs, we can just double it, and we'll have our total surface area. So this is equal to 50 plus 80 plus 40. So what have we got? We've got 170. And so we take surface area is equal to 170 times 2. What's that going to be? Is that 240 centimeters? And because it's an area, it's squared. So if you were to flatten this out, you'd need 240 centimeters squared of sheet metal or whatever material you're using to create this cuboid. Cool. Hopefully that makes sense. So we need to calculate the face of each side. Let's have a look at something else. Might want to just give this one a go. Surface area. So first thing you notice, this is a triangular prism. And what I noticed when creating this problem is you actually need quite a bit more information than you might do for the volume of certain things. So we need to calculate this face and this face. So I might just say, I might do this working a bit more pedantically. triangle face. So that's going to be, area is a half base times height. So it's going to be a half times 5 times the height of 3. So that's going to be a half of 15, 7.5 centimeters squared. Okay. And now we want this rectangular face. I might just go rectangular faces. Well, here's one, 6 by 10, plus, apologies, these should be the same length, so that's 6 by 10, plus we have a 5 by 10 on the underside, so it's quite hard to visualize sometimes, so that's 5 by 10, so that's all the rectangular faces, 60 plus 50, and that's going to be, so I'll go area is equal to, so the area is equal to 170 centimeters squared. And then what I usually do is I go surface area, capital S subscript capital A, and it's going to be 170 plus, I got 2 of those triangle faces, 15 centimeters squared, so we get 185 centimeters squared on the surface. So I've got the triangle faces 1 and 2, they're there, and then I've got 1, 2, 3 big rectangular sides. So if I was trying to draw the net for this, it might look, it would have 3 rectangles kind of all laid out like that, and then there would be 2 kind of triangles coming off one of those. So you can imagine if I folded these up and they met at the point, then I could lift these 2 triangle pieces up and they would just connect. So that's a triangular prism. Hopefully that makes sense. Second to last problem is the cylinder. Now this is quite interesting because if you were to unravel the cylinder, what sort of faces would you get? And so I'm just going to show you quickly what would happen when you unravel a cylinder. So imagine I've got this roll of tape here. So imagine that this is the curved side. Well, if I took that curved side and I unraveled it, well, what shape do I get? Well, that looks to me like it's a rectangle. Okay, so if that's a rectangle, then this is, I need to know this length, but I need to know the total length around the outside. So if I was to unravel this, it would kind of look like a rectangle with 2 kind of circle pieces. So if I raveled this back up and then put the circle and then fold the circle pieces down on top, I would get a cylinder. Now, can you tell me what we call that length there around the outside of the cylinder? Hopefully you thought circumference. So the first thing we need is circumference. Well, that's equal to 2 pi times radius, isn't it? So 2 times pi times 5. So circumference is 2 times pi times 5. 31, well, yeah, I should have known that was going to be 31.4, shouldn't I? 31.4 centimeters. So let's go area of rectangle. Or you might want to say the curved surface. This is kind of a curved surface, but this is more, the surface itself is curved, whereas this surface is flat. So area of rectangle or curved surface, that area is going to be this length times, it's basically its base times its height, isn't it? Well, its base is actually 31.4, and we times that by its height of 20. So that might be 628 centimeters squared. 31.4 times 20, 628 centimeters squared. And then we want the area of the 2 circle parts. Circular face. So the area of the rectangle we've done, and we want the area of the circular face. Well, its area is pi r squared, isn't it? So it's pi times 25. So pi times 25 is 78.5. So the surface area is 78.5 times 2, there's 2 of those circular faces, plus 628 centimeters squared. So let's have a look at that. 78.5 times 2 plus 628 is 785 centimeters squared in material. Awesome. And just to give you a quick understanding of the volume of this, that is 78.5 times 20. So look at that. You can have 1,570 centimeters cubed by only using 785 centimeters squared of material. So a cylinder is quite useful for storing things, especially liquids. Last problem, just want to challenge us a little bit. This is a trapezoid prism. I think I spelled that wrong. Trapezoid prism. So there's a lot of faces on here. So we've got 3 meters height here, 4 meters, 11, 6, 4, and 5. And these lengths obviously the same. And these lengths all the way down here are the same. It's got the same width all the way through. So how many faces are we going to have to calculate? What is this one? There's this one on the front. There's that one on the back. So that's 1, 2, 3. Then we've got 4, 5, 6 faces. Is that right? 1, 2, 3, 4, 5, 6. Yeah. I guess you could collapse this right down into if you squished it all, it would actually create a dice, wouldn't it? If you put it all back down to a square. So area of trapezium. Well, remember the area of a trapezium is a plus b over 2 times the height. So that's going to be 5 plus 11 over 2 times 3. So that's going to be 16 over 2 is 8 times 3 is 24 meters squared. And now we're just going to calculate these rectangular faces. So rectangular area, we have a 6 by 4. We have a 5 by 4. We have a 4 by 4 on the back. And we have an 11 by 4 on the bottom. So the total rectangular area is 6 times 4 plus 5 times 4 plus 4 times 4 plus 11 times 4, 104 meters, isn't it? Squared. Now we have 2 of these trapezium faces. So surface area is 104 plus 2 of these things, plus 48. Can I do this one in my head? I'm going to say it's 152 meters squared surface area. And I'm going to check it because this is permanent, isn't it, this video now. So that is surface area, and those are a few problems you might want to just go back, maybe have a look at and have a go yourself. Like that smash button.